Hello everyone and welcome back to Noble for GCSE. So today we're going to be looking at GCSE OCR Computer Science Paper 1 and Paper 2 revision. We will try to cover as much as we can within these 1 hour and 40 minutes that we have. We're going to begin on the first topic, which is computer systems and system architecture. So I'm going to be doing the mind maps on the board on screen, and hopefully you can do some blurting with me to show your knowledge. So we're going to begin by what every single computer system needs. An input device, an output device, and storage. These are the four key components of any computer system. Now, if we look further into this, the CPU is made up of three components. These three components are the main memory, which is known as the RAM, the processor, and the cache. Now, the main memory, or the RAM, actually we'll look at that secondly. Processor first. Processor. Well, the processor is the main part that processes all the instructions needed. Now, the processor contains the following: the control unit, the arithmetic logic unit, and the registers. Now let me just make this bigger. Okay, control unit, the arithmetic logic unit, and then the registers. So let's look individually at what each part is for. So the control unit's function, the function of the control unit is it coordinates and manages the CPU. So it coordinates all of the activities within the CPU. It's like the manager, the sub-manager. The CPU coordinates all of the activities in the computer. It does things like execute code, decodes code. It regulates the processor timings, etc. Then we have the ALU. Now the ALU stands for the arithmetic logic unit. So it carries out all logic operations as well as all arithmetic operations. Logic being like binary, zeros and ones, subtraction, multiplication, and division. And also it contains the accumulator, which stores this, but that's the type of register, so we'll go into that later. It also does shifts, like binary shifts. And finally, registers. So in terms of registers, we have different types of registers. So we have the MAR, memory address register, MDR, the PC, the program counter, the current instruction register, CIR, and then the accumulator. So just visiting each one, the MAR's function is it holds the address of, is where the address of the current instruction is fetched. Now, in terms of the MDR, if MAR is where the address is fetched, MDR is then where the data is fetched. Now, PC stands for program counter, and what happens is it increments to the next program. The CIR is the current instruction register, and this just holds the current from the MDR. So holds the current instruction, and it gets this data from the MDR. Now we'll look at the steps in the fetch decode execute cycle in a second. And finally, accumulator, the accumulator of the calculations and operations done in the ALU. It's a temporary store though. So if we could just go over that again, just to make sure you understand your knowledge. We have the CPU. We'll go over that again once we've done the actual RAM as well. So let's go through the RAM and the main memory and what the purpose of that is. So the main memory is there because when a program needs to be executed, this is just an explanation. When a program needs to be executed, it has to be loaded from the hard disk to the main memory. And the reason why is so that the processor can access it at any time. So currently, so what happens is for the main memory, the programs need to be loaded onto the main memory for the processor to access them. Now, the reason why it's called random access memory, the random comes from the fact that the data can be accessed at any time and in any. So that's the benefits of RAM. The data can be accessed at any time of the day in any order. Now, RAM, in terms of the properties of its storage, acts as temporary storage, which is what we like to call volatile. So it's a temporary storage of a program while that program is being executed. Now, we actually have other forms of memory as well. So let's do that in grey. So other memory forms include things like ROM, virtual memory. So ROM is a type of non-volatile memory. So what that means is that it is not temporary. It's a permanent store, and once it is initially edited, it cannot be edited after that. It retains its data even when there is no power. An example of programs that are kept in the ROM is the basic input-output system, which is the key to starting up the operating system and does not need to be changed, and therefore is a good example of how that can be used. Now, in more detail, the computer has a piece of software called the bootstrap loader, which you may not be familiar with, but you may be familiar with the term booting up a computer. And where that actually comes from is the fact that you're booting up a computer every time you're restarting it from scratch, because bootstraps comes from the phrase to pull yourself up from your bootstraps, which means to start again. And it's just talking about how the bootstrap loader is all the code that restarts an operating system. So that should help you. Now, we don't only just have ROM, but we also have virtual memory. Now, virtual memory is when secondary storage, things like the hard disk drive and the solid state drive, both of these act as extra RAM when the RAM is full. So this is virtual memory. It's called virtual because it's not really true. So what it does is it stores the running programs that's parts still need to be accessed by the processor, but there's just not enough space to. However, the access speeds are still quite slow. Now, in terms of how we decide the main memory needs to get its programs, the processor needs to get the programs from the main memory, and there needs to be some communication between the programs. We call this communication that's enabled buses. By buses. So buses are things that allow the communication of data, and there's three different types. There's the address bus, the data bus, and then the control bus. And these three buses then allow for the programs to move between the processor and the input. Finally, the cache. Let's look at the cache. So the cache is this really rapid data that's used to store used as a temporary store, actually, for all of the frequently used data. So what's key information here is the fact that the cache is a rapid data retrieval method for frequently used data. So it's very fast. There's different levels of cache: level 1, level 2, level 3. And level 1 is the fastest. Level 2 is the slowest. However, level 1 has the smallest capacity, and level 3 has the highest capacity. Now, the cache is a method that increases the CPU's performance. Now, there are other things that increase the CPU's performance as well. So let's look at them now. Other factors. So we've discussed the levels of cache. Some other things include the Some other things include the clock speed. and the processor timings, or the processor cores. So the clock speed is how fast basically the speed of the processor. However, it's not always an increase in clock speed equals an increase into the CPU's performance, because of the fact that the CPU's performance depends on a plethora of other factors, not only just things like the clock speed. Now, in terms of processor cores are used to execute different programs. So it allows the one core is responsible for one program at a time. But if there's a dual core, this means that two programs can be done simultaneously. And if there's a quad core, that means that four programs can be done simultaneously. So that's what processor cores are. But it's not necessarily increase the CPU's performance, because you're only able to use it when the computers are designed to be able to fit it. And if the software isn't matching the amount of processor cores, then it would just work at its minimum capacity. Now, in terms of clock speed, just think of it that everything in the CPU that is done at everything. Everything is done as a tick of a clock. So if you therefore have a faster clock, well, that then means that most of the instructions will be faster. It's actually measured in hertz. So one cycle per second is called 1 hertz. But you don't need to know too much into that. Okay, so we've looked at the bottom layer now. And let's just do a bit of revision over that layer before we move on. So in terms of revision, we have the CPU. The CPU, for any storage system, we've got the input and the output. Now the CPU is made of the processor and the cache. The processor is made up of the ALU, the CU, and the registers. And the ALU is where all the logic operations, as well as the addition, subtraction, multiplication methods are all done, as well as shifts. The control unit controls all the activity. And then the registers are super fast forms of volatile memory. So very fast memory locations. So in terms of the different types of RAM of registers, we then have the MAR, MDR, PC, CIR, and the accumulator. So the MAR fetches the current address of the instruction being done. The MDR fetches the data of the current program. The PC increments to the next instruction. The CIR holds the current instruction from the MDR. And finally, the accumulator holds all of it's a temporary store of everything that happens in the ALU. Now that's the process all done. So the RAM is needed because of the fact that in order for a program to be executed, it needs to be accessed by the processor within the RAM. So any instructions that are being done need to be copied into the RAM in order for the processor to access it and to retrieve it. Now it's called random because you can access it at any time in any order. And overall, it's a temporary form of storage that holds programs. It's a temporary memory that holds programs currently running. Now, there's also some other forms of memory, and then there's virtual memory. So ROM is a non-volatile form of memory. It retains the data without power. And in terms of some uses of ROM tends to be used for the basic input-output system and also the bootstrap loader, which comes from saying to pull yourself up from a bootstrapping system. Now, virtual memory is when secondary storage, which we're going to look at soon, begins to act as extra RAM to hold more programs that need accessed but don't fit. Now, in terms of the cache is a super fast memory location that's used to hold frequently used data. Looking more specifically at it, we have the level 1, level 2, and level 3 cache. And in terms of speed, comparison to memory, this is the best speed. So this is the best speed in that order, and then this is the best memory capacity in that order. Now, there are other forms that affect the CPU's performance. So we have the clock speed, and we have the processor cores. So the clock speed is the speed of the, because everything in a computer runs by the tick of a clock, so the faster that clock ticks, the quicker everything will get done. So normally, the increase in clock speed could increase the CPU's performance, but it doesn't generally do so because it is dependent on a plethora of other factors as well, contributing to it. Now, we also have processor cores. So a single core allows one instruction cycle at a time. So the more cores, for example, a dual core system, will then allow 2 instructions to be carried out simultaneously. And logically, the more cores, the more instructions, the faster it will be. However, there is a big but here. A computer needs to be able to function with this amount of cores. A computer, as well as the software, need to be able to function, and if not hardwired to facilitate a core that's out of their range, for example, if they can't do more than double core, then they'll only use the maximum they can do, which is limited. Okay, so that's what we looked at. That's a little summary, and that's the first time I went through it. So it's also important to know about the fetch, decode, execute cycle. This involves a lot of what we've just put here. So let's write out the stages of the fetch, decode, execute cycle now. And it's called the D and the E. So the first stage is that the memory address is copied from the PC to the MAR. Then what happens is, after the address is copied from that, the PC then increments. You can then say simultaneously as the PC increments is fetched in the MDR. So then that's a lot of the fetching done. So it's actually fetched from the MDR because it went from the MAR to the MDR. So you can say one or the other. And then after the data is fetched, then what happens is the contents are copied from the MDR to the CIR. And then we have it in the current instruction register. And what happens is the CU decodes the instruction within the CIR. And as the CU decodes the instruction in the CIR, it sees what it needs to do next. And then finally, the instruction within the control unit, for example, whether it's fetching data, adding data, multiplying data. Now, this is all on the basis that it is a single processor core, number one, and secondly, that it's a clock speed or single memory form. So let's just go over that one more time because a lot of people forget these. So the fetch, decode, execute cycle. We have the address that's fetched from the PC to the MAR. The PC then increments. The data and instruction is then fetched from the MAR to the MDR. Then the current instruction register, the contents is then moved from the MDR to the CIR. And the reason why it's moved from CIR is because the CU can decode the instruction in the CIR. And then the CU then executes whatever the instruction is. And this could be to do with an OU, it could be calculation, it could be data, whatever the instruction is. These are the protocols. Now, just a bit more about embedded systems now. So, an embedded system is a device that uses a CPU or what we call a microprocessor to control their function. This is an embedded system. An embedded system is anything that uses a CPU or a microprocessor in order to control its function. Now, the control is usually on a single microprocessor stored within a device, a control system. Now, with a control, so we have an embedded system here. We have a CPU and a microprocessor that's controlling all of its functions. Then we have a control system. Now, control system usually is on a single microprocessor, and all of the things are stored within this one device. So with a control system, you do not need an operating system because of the fact that the tasks are simple and repetitive. Okay. Now requires the main part of this. We're now going to look at storage, the upper half of the mind map. So storage forms. In terms of storage, there's two different types of storage that we look at. So we look at secondary storage, and then we look at optical storage. Not optical storage, cloud storage. So we have secondary storage, and then we have cloud storage. So in terms of secondary storage, let's just look at what secondary storage is first of all. In terms of some key bullet points, secondary storage is non-volatile. It retains the data. If you think of a memory stick, you don't want it to lose the data after the power is off. You need it to keep it. So it's a non-volatile form. Now, it actually holds more data than the RAM. And it's relatively cheap to access as well. One disadvantage, however, is that it has slower access speeds. Because what happens is when you connect a secondary storage device to the system, the main memory has to go and then fetch it all the way from the secondary storage. Whereas if it was a frequently used instruction, the CPU would just go to the cache. Okay. So there's some properties of secondary storage. Storage. So the first one is magnetic devices. We have magnetic devices, then we have flash or solid state memory. And then we have optical storage. So if we take a deep dive into each of them, magnetic devices, the polarity, so it depends on the polarity of the track, which is either north or south, and what we have is a handle that moves around and above these. So there's a handle that moves above this magnetic thing, and it measures whether they are north or whether they're south, and therefore records this as a 0 or 1 binary value. Now, overall, in terms of advantages and disadvantages, can look at them now. So advantages of a magnetic device is things such as it has a huge capacity, and it can be portable and suitable for desktops. Now, in terms of some disadvantages, it has a moving head, and this moving head is therefore susceptible to damage. Furthermore, because there is the fact that you're reading the polarity of each cell, that then means that it's vulnerable to magnetic fields. And another factor is that it's quite slow to read or write to. So it's slow, is vulnerable, and it can be susceptible to damage. However, advantages, it's got a huge memory capacity and it can be portable. Now let's move on to flash or solid state memory. So in terms of advantages and disadvantages, so advantages of flash memory is A, that there's no moving parts. Therefore, it's one of the most reliable forms of secondary storage. It's lightweight and thin. And it has also got a low power consumption. Now, if we look at the disadvantages, by contrast, the access speeds are still slower than the RAM, but it's going to take a vast amount of technology to make it as fast as it would be within the RAM. Now let's look at optical storage. So optical storage is just this idea that the reflected light, so the reflected light off of the lasers, then creates these pits and lands on a disk that is red, which can be viewed as different values. So if there's a pit and if there's a LAN, it can be read as different values. And this is normally found on CDs. Now there's some different examples of optical memory, such as CD-ROM, CDR, CDRW. So what we're saying here is that we have CD-ROM, CDR, CDRW. CD-ROM means read only. CDR means it's recordable. And CDRW means you can read and you can also write. Now let's look at the advantages and disadvantages again, shall we? In terms of the advantages of optical memory, it's lightweight and it's portable. Disadvantages, however, it's very easily damaged and scratched. And it's also vulnerable to sunlight. Finally, let's move on to cloud storage before we've now revised systems. So cloud storage is when you are saving information. So saving your data in an offsite storage system that is maintained by a third party. Okay. So cloud storage is when that you're saving data in an off-site storage system that's maintained by a third party. Now, in terms of advantages of cloud storage, you can access data from anywhere in the world. Another advantage is that backup is not an issue because of the fact that the third party manages it. Some disadvantages, however, include things such as the security concerns, because of that the data is managed via the internet, and therefore hackers can be found on the internet, so it puts to question the security of that. And furthermore, the fact that you need an internet connection means that it's dependent. And that is this first topic done. So that is all of systems architecture now done. So well done. We got through that before we rejuvenate and restart. Okay. Now, before we just completely abandon this topic, let's just go over a bit about storage capacity. Does data capacity and calculating data requirements? Let's look at that. So, storage capacity. The smallest unit of data that a computer can represent is called a bit. Its value is either 0 or 1. Now, a group of 4 bits is called a nibble, and a group of 8 bits is called a byte. Because these units are so small, larger units are typically used to describe the size of data. So, kilobytes is 1024 bytes, megabytes is 1024 kilobytes, gigabytes is 1024 megabytes, and you can see where I'm going with this. So here are when we're comparing storage capacities, that is what it will look like. Now, to calculate how much data that can be stored within a certain capacity, you need to know 3 things: the size of the data, the available space, and how to convert between the relevant units. So if the size of average digital photograph is 8 megabytes, how many photographs can be stored on a 32 gigabyte SD card? So all you have to do is you have to convert the available capacity from gigabytes to megabytes by multiplying by 1024. We are now on to networks. We're going to look at wired and wireless networks. So let's look at our mind map again. We're going to create a whole new mind map now. And we're going to call this mind map networks. So the first thing we're going to look at, as shown by this PowerPoint slide, is the type of networks. Okay, because there are 2 types of networks that you should be aware of: local area networks and wide area networks. So let's look at local area networks and wide area networks. Local area networks. So local area networks are used for a small geographical area. It's when all of the computers are connected physically through use of on a single site. So a single site where all of the computers are connected. Now, local area networks are often owned by and managed by a single person. So local area networks are on a small geographical area. They are on a single site because all the components are connected and all the computers are connected, and they're often owned and managed by a single person because that's how small it is. So in terms of some advantages and disadvantages to this system of local area networks, let's look at the advantages. So advantages of having a local area network are things like, firstly, the folders and files can be accessed via any computer. Secondly, there are shared peripheral devices, which are also show benefits in order to share other things. The internet also has a shared connection, meaning that there's only authorized users because of the fact that there's an internet shared connection. So how does an internet shared connection enable only authorized users? Because of the fact that it's a shared connection, it means that it won't be intercepted by hackers because it's only within this single site that it exists. Okay, in terms of disadvantages of having a local area network, the first one would be that if you were to manage a larger local area network, it would be quite complex, like a massive building or something like that. And also, if there was an infection from a virus, it would then infect the entire system. So there's the advantages and disadvantages. Now, in order to connect to the internet, local area networks, this is just some extra information, local area networks need something called a modem. So you only need one node, which is one device, to connect to this within a local area network in order for there to be internet. Okay. Now it's important to look at the topologies. So topologies are just the way in which different networks are organized because there needs to be a system in place. So let's look at some of the network topologies. So there's two main ones we have. We have the star topology, and then we have the mesh topology. So in terms of the star topology, what this is that all computers have their own cables which connect them to a switch which routes all the messages. So let's say that again. We have all computers, and each computer has their own cables connecting them to the switch, or connecting them to a switch which controls and routes all the messages. So what this is imagine we have a server, which is a really powerful computer. So a server or a switch, for example. A switch in the center, and what happens is each computer is individually connected to that switch. And that's why it's called a star, because it could provide the impression that it can create a star, because everything is connected to the middle. Alright, so that's what a star topology would look like. Now, in terms of some advantages and disadvantages, advantages is that if one cable fails, it's not affected, the whole network isn't affected. So let me write the advantages in green. So advantages, if one cable fails, the whole network doesn't. Now, another advantage about the star topology is that it consistently performs even with heavy use. So it doesn't slow down even if it's overcrowded. So that's the star topology's advantages. Now let's look at the disadvantages of having a star topology. Firstly, the costing. It would be very expensive because of the fact that each computer would need their individual cabling, which is also a lot of hassle when there's a lot of cabling, and there will be extra hardware, for example, a switch. And furthermore, if the server or switch goes down, so the switch can be here, but also a server can be in the center, which is a super powerful computer. So if the switch or server was to go down, then the whole network is down. Okay, so that's the star network topology. Let's look at the mesh network topology. Now, the mesh network topology is when each node is connected to every other node. So this means that, in partial mesh, some nodes are not even directly connected to one another. So in this system, each node is connected to every other node, or is connected to another node. And in a partial mesh, not all the nodes are even connected. Okay, so what we're saying here is that each computer is connected to another computer, or each node is connected to another one. Now, this is an example of a wireless LAN network. Now, let's debunk that. So, what does wireless LAN network mean? Well, first of all, it suggests that there's no cabling ever, and it also suggests that there is no central connection point. So unlike star, where you had the server or the switch in the center, in the mesh network, it's because it's a wireless because it's a wireless LAN network, there is actually no central connection point. So instead of there being no central connection point, each point on the network then acts as a node, hopping data from one point to another to get to the quickest and easiest route. So because of the fact that there's no central connection point, what happens is the data then routes and travels via each node to get to the receiver the quickest way possible. So let's draw out an example of a mesh network. So we can have computer 1 connected to computer 2. Computer 2 can be connected to computer 3 and computer 4. Computer 4 can be connected to computer 5, and computer 3 can be connected to computer 6. Now we have all of these connections. So if something wanted to get from, let's say, computer 6 to computer 1, it would find the quickest available route, which seems to be going this way, going to computer 3, then going to computer 2, then going to computer 1, and then it would travel that way. Whereas if it was computer 3 wanting to go to computer 5 here, the computer 3 would go to the switch and then that. So every transaction has to be done by the switch or the server here, but here it does not have a permanent fixed route. So let's look at the advantages and disadvantages. Now, the advantages of a network such as this goes as follows. Firstly, there are fewer cables. Fewer cables then therefore means less cost. Second advantage, the more nodes, the faster the network. So actually by increasing the network and increasing the components of the network, you're actually increasing the speed and strengthening the network. So it's actually really interesting how that dynamic works. And furthermore, when new nodes are added, there is no adjustment needed from the administrator. So new nodes are added easily. And finally, the local network doesn't have to travel to the central switch, which again, as we said, it's faster. It's faster, especially for LAN, because you don't have to travel to a switch before you go anywhere. Especially if, for example, you wanted to go from switch number 4 to switch number 5. Here, you can easily do that in one method. Whereas here, if you wanted to go from 4 to 5, you'd first have to go to the switch and then have to go to 5. So that's an extra, it would take double the time. Okay. We've looked at the two different topologies. Now we're going to look at Ethernet and what that means. Now, Ethernet links to local area networks, which is why we're doing it across this topic. So when we're talking about Ethernet, Ethernet just means the protocols used in a wired network. The widely used protocols in a local area network. So specifically, when we're talking about wired networks, we mean local area networks. Obviously, the internet and things that are wide area networks can't be an Ethernet connection because you can't be wired connected to someone in, I don't know, Alaska right now. That's just going to be a lot of cabling through the Earth's core. So, an example of Ethernet, similar to polite human control. So nodes can only transmit when their network is quiet. So what this is saying is that two nodes can simultaneously transmit data. That are simultaneously transmitting data will have to wait to reattempt. So Ethernet systems are very polite. Polite little systems where nodes will only transmit data when the network is quiet. It won't transmit data if two nodes end up simultaneously transmitting data, at least one will wait until reattempting. The Ethernet systems divide up data into frames which are called packets. Now, the packets contain certain key bits of information that are vital for it doing its function. Now we'll look more into depth in this, but firstly it has the source and the recipient. Then it has the MAC address. And then it has error checking data. Now, when we're talking about wired networks and the Ethernet, we need to have transmission media, which are just methods about how we can transfer all of this data. So let's look at transmission media. So a standard network has either a copper cable or a fiber optic cable. So copper cable or fiber optic cabling. So let's look at copper cabling in terms of advantages and disadvantages. Copper cabling is cheaper, firstly. It's also built in. It's got built in for the NIC, and it's already in use right now. Most people are used to it, and therefore most people will understand it. In terms of disadvantages of the copper cable, it has affected interference. Now copper loses 94% of its signal strength. After 100 meters. Whereas in fiber optic cabling, it loses only 3% signal strength. So that's a massive, massive differentiation. It only loses 3% of its signal strength after 100 meters. Furthermore, well, that's actually an advantage, more like, but yeah. We have a greater bandwidth with fiber optic. We have faster transmission. And the cables do not break as easily as well. So in terms of looking specifically, fiber optic is made of the materials glass and glass fibers and electricity, and copper cable is obviously made from copper. And overall, we can see that fiber optic is the best. One disadvantage again is that it's more expensive. Now we're going to look at things like bandwidth in a second as we move on to factors affecting the network performance. But I just want to look quickly at the configurations of networks, the different configurations. So there are two different types of network configurations. There's peer-to-peer and client to server. So peer-to-peer networks are when are used in smaller offices because it's not practical or cost effective to have a specialized server. So peer-to-peer configuration is actually a cheaper alternative for smaller networks that don't necessarily need a switch or a server to work. Now, what happens is, like we were looking at in terms of the mesh network, they're all connected to one another. Computers are connected to one another. And then it can only access data and information when the rights have been granted. Now, the storage facilities within a peer-to-peer network tends to be distributed amongst the individual computers. Now let's look at a client-to-server model. So a client-to-server is when you have the server, which is the very powerful computer, and all of the resources needed by the client then requests and sends requests to the server. Now, the central backing up of the files happens centrally, and in order to access the files, you then use a file server. And we're going to talk about that in more detail as well. Works. Okay, so wide area networks. An example of a wide area network is the internet. Now, the internet is used for emails and messaging. That's the usage of the internet. Now, overall, if we were to define a wide area network, we would say a collection of computers which are connected using resources supplied by a third party. So a collection of computers connected together via using resources supplied by a third party carrier. Regular shop, and everyone bought their individual items from there. So you have customer 1, customer 2, customer 3, customer 4. The internet is basically a collection of these computers that all go to the same, that all take their resources from the same third-party character. So imagine, instead of this being a shop, it's now the internet. And what this is a collection of computers here, all using the same resources of the internet. So this is what you call the wide area network. So yeah, going back to what we said about the internet. The internet is used. Now, we need to know a little bit about how the internet works. So let's look at that first. So in order to be connected in a network, first of all, you need a couple of different things. NIC is a main thing. And NIC stands for Network Interface Card. And in order to connect to a network, this is what you need. So, needed to connect to a network. So everything that connects into a network, your phone, your computers, whatever devices you have, needs to have an NIC and probably does have an NIC built in. Okay. The next component, MAC addresses. So MAC stands for Media Access Control. Now, every single NIC has a MAC address assigned to it. Okay? So, a computer may have more than one MAC in a wired network. The MAC address when they're in not a wireless network. So, computers can have loads of different networks. So imagine we have computer 1 here, and computer 1 wants to connect to loads of different networks. First of all, Bluetooth. Then it wants to connect to the internet. And then it wants to connect to a local area network. So you have different networks, and what happens is, in order to connect, firstly you need a network interface card within it. And then what happens is every single NIC has a MAC address assigned to it. And there can be different MAC addresses. So a MAC address for the Bluetooth connection, MAC address for the local area network, the MAC address for the internet. Now, MAC addresses are 48-bit addresses. And there are 48-bit addresses. They are actually written as hexadecimal. And because they're written as hexadecimal, it's easier. So there's actually 12 hex values. The first 6 are identifying the manufacturer, and the next 6 are for identifying the serial number on the device. So, in conclusion, has a unique, unchanging MAC address. Okay. So now looking into this, we're now going to look a bit more into the domain name system. DNS stands for Domain Name System. So the domain name system has databases and databases of every single domain name and its relevant IP address. So what happens is that it translates the domain names into the IP addresses. So the DNS is a massive database containing every single domain name and the domain name as well as the IP address. And what it does is whenever you send a request, it then undergoes this conversion. This is the steps of this which we're going to focus on in now. So there are several domain name systems across the world, and they regularly update and communicate with one another. First of all, that's a key important thing. They update one another, because obviously the IP address wouldn't change, but the domain names can change. So as one updates, then it then updates the rest of them. So what you would do is, first of all, The internet itself is not owned or managed by anyone, and it then can be accessed by anyone. First of all, just to know, all of the information on the World Wide Web, on www, is stored in documents. We call these documents web pages, so let's just make a separate note of this, because I want to prepare you with all the information before I tell you about the structure of how we retrieve this information. So all the information that's stored on the World Wide Web is stored on documents, which are referred to as web pages. Now, these web pages are accessed through programs called web browsers. So then we move this back. So we've got something called web browsers, the documents which have the web pages on them, that have the information we want. So just going back over it, on the World Wide Web, all of the information is stored in something called web pages. Now, in order to access anything on the World Wide Web, you first have to go into the World Wide Web. You then have to go onto a web browser, and then you go and open up the web pages. So that is the structure. And now finally, let's look at the DNS. So, the massive database containing the domain names and the relevant IP addresses. So what we're saying here is that your domain name is what you type into the browser. So let's imagine we have the steps right here. So step 1, type name. So for example, on the web browser, www.hello, for example, right? So you type in the domain name. Then what happens is this request gets sent to the DNS. The DNS then converts the domain name that you requested as the IP address of that domain name. Now, the whole purpose of the domain name system is because of the fact that humans cannot remember the IP addresses and will not remember the IP addresses of each individual web page on each individual web browser. It's just too much information. So having this system an advantage to have to remember the IP addresses. Again, if the IP addresses then changes, we also can still use the same domain names because, as we said, they will regularly update itself up. And furthermore, everyone has access to a local domain name system, which is 3 reasons why the domain name system is a good system. Now, the IP address, let's hone in a bit on the IP address because we haven't focused too much on that. So the IP address is something that changes every time you move past an invisible network boundary. So every time you move past an invisible network, you're changing. So you could be in your house, okay? And then this has its own network boundary, your inner house network boundary. And then you could be walking by some shops, for example. And then as you walk past the shops, you're walking past loads of network boundaries. Okay? So your IP address would then constantly change as you walk past them. So in general, the difference between the MAC address and the IP address is the MAC address that is assigned. However, the IP address changes every single time you move across an invisible network boundary. Okay. Now, in terms of what is exactly your domain name, because we talked about typing in a domain name. So, what is a domain name? So, a domain name is just the text reference that can be translated as a domain name because humans can't remember IP for a website for an IP address. Now, when we're looking at IP addressing, every computer device within a network has a changing IP address because their location changes. Okay. Now, there's one more thing we need to look about the internet because that's quite a lot of information, but we need to know one more thing with hosting. So, hosting is once you have an internet host, which is often an ICP. A host is a company that stores your files and makes them available to you from other internet connected devices. So let's go through that definition again. What is an internet host? So, an internet host is something that internet is something that is a company that stores your files and they make them available to you And how do they make it available to you? They do it from other internet connected devices. So I'm going to see if I can find an example of an internet host. Here's an example. So, when setting a website up, they need to use a web hosting service in order to make it available on the www. So far, we know that we've got in our system, we've got the web browser, which allows you to get to the internet. Now, if you wanted to set a website up, what you would need to do is you need to make sure that you use a web hosting service that makes it available to you and that makes it available on the World Wide Web. So to make your information that you want available on the World Wide Web, you have to go through the web hosting service. Now let's look at circuit switching and packet switching, which is found within a wide area network here. So, what is the difference between circuit switching and packet switching? So circuit switching is when you are on the phone to someone. Okay. And when you're on the phone to someone, you're therefore making a dedicated connection and the person being called. So circuit switching is talking about when you're telephoning someone and then you're setting up a connection between you, the caller, and the person being called. And this is called circuit switching. Now, packet switching is ways in which a file is broken up. Now, a file is broken up into packets, and each packet is sent along a different route, so the fastest route possible. Now, the packets are given different headers. So, in order for the information to be retrieved and sent successfully, you need certain bits of information. So, firstly, you need the IP addresses. Where are you sending it to? So, of the sender and the receiver. You're also going to need the sequence number, because what happens is each of the packets basically split the data up and then they're numbered in their order that they should be. And then we need to know the sequence number so that we can put it back together. The next thing is the number of packets. That's also quite important. And then error checking data. Now we're going to look at factors that affect the network policy before we return to a bit more about packet switching. The network performance are two things: bandwidth, three things: bandwidth, errors of transmission, and latency. Okay, so bandwidth is the main factor per second, and what it is just the higher the bandwidth, the faster the data is transferred. So it's the speed at which data is transferred. Now, errors of transmission are things that are prevalent within a network that therefore causes the data to have to be retransmitted. Now, finally, latency. So, latency is a time delay between the moment that the packets were. So, it's basically telling you how long it takes for the packets to be sent and then received. Now, within a network, we have different layers. They're referred to as the layers of a network, and they're responsible for all of the individual parts. So let's look at the layers of a network. We first have the application layer, We have application, we have transport layer, we then have link layer, we have internet layer, sorry, and then the link. Okay, so the application layer is the encoding stage. The encoding data. So what happens is the data is encoded. The transport layer is when the data is split into packets. And its order. The internet layer attaches IP addresses to of the packets so that the recipient knows the sender's address. So IP addresses. And the link layer sends the MAC addresses of the sender and the receiver, and it's directed to a specific device. So let's go through this again. So we have the application layer, and within the application layer, we see that in the application layer, we see that the data is being encoded. So data is encoded. Within the transport layer, it's then split up into packets. Within the internet layer, it's then given an IP address. And then within the link layer, it's assigned the MAC addresses. It's assigned the MAC addresses, and it's also assigned to the device that it's going to be sent to. So that's a summary of those events. Wireless networks, advantages in terms of thing is it lets suppliers adapt protocol software to specific hardware by only having to change one network layer. So layers are really good because they allow you to adapt your software to specific things. You only have to edit one layer at a time. And yeah. We also have Wi-Fi, which is another example. So encryption prevents data from being hacked. So you've got plain text, which is normal messaging, ciphertext, which is the encrypted message. Encryption is when it's turned from plain text to ciphertext, and the key is a sequence of numbers to encrypt it. So security measures. So wireless is dangerous because of the fact that most devices can detect Wi-Fi hotspots when in range. So you can do security measures such as disabling the broadcast of it, hiding the network, restricting accesses to specific MAC addresses, and using Wi-Fi protected areas encryption. So a typical network will have a hotspot. The hotspot is basically around the wireless access point, and this is where it's possible for any device to gain illicit access to the wireless access point and the network. So it's very dangerous if criminals were to stand by the hotspot of the wireless access point and gain access, because it then can allow the intruder to bypass the firewall and between the physical network and the broadband connection. It can also cause bandwidth stealing, which is when you introduce slowing network down, and confidentiality, the access to unencrypted confidentiality as well. Now, let's quickly focus on the network hardware. So let me try and show you if it's in this document here. There's three main network hardware pieces that you need to know. We've got the network interface card, which we talked about, the router, and the switch. So let me just find the PowerPoint slides relevant. Okay. Okay. So here is the network hardware. So firstly, we have the network interface card. Now, as you can see, in order to connect to a network, you need a network interface card. It provides a bridge between a device and a network. Now, you don't need to know the final two bullet points. All you need to know is that it's required and it can be wired or wireless. That is what a network interface card looks like. And you can see it connected on the right hand side there. The next thing is a switch. I don't know why it's spelled like that, sorry. A switch, and then in a network, a switch is this piece of hardware that allows multiple computers and devices to connect together. So switches are only used in a wired network, and therefore it can only be used in a local area network. And what happens is it forwards the packets to the intended recipient using MAC addresses. So a switch basically acts as a director in a wired circuit, and it forwards a packet to the intended recipient using its MAC address. And that is what a switch would look like. Okay, and finally, routers. So routers route data packets across a wide area network. So a router almost does the job of a switch, however, for a wide area network. So what happens is each router acts as a node, and it's passed from router to router till it reaches its destination. So if it's destined for a local area network device, it can be routed up into a switch, and then the switch will then deal with it from there onwards. So what happens is they look at the IP address within the data packet and then determine whether the destination is in the local area network or not. If not, then it's passed onto the connected network, onto the next router. We also have wireless access points. So this is hardware that connects to a network switch, and it allows Wi-Fi devices to connect here. However, because the radio waves that wireless devices use to communicate are open, this then has many issues. I know it uses encryption, but we talked about the hotspot difficulties. That is what a wireless access point looks like. Now, overall, if you were asked to define a wireless access point, I would say a wireless transmitter that receives data from a network via its physical connection. So a wireless transmitter that receives data from a network via its physical connection. It converts data into the radio waves and transmits this data. It can be accessed by any device into a radio signal with a Wi-Fi adapter. So it's needed for a Wi-Fi. There is a video here if you want to watch about comparing the network devices. So we talked about transition media, so we can then move on from there. So in terms of factors that affect network performance, we've talked about bandwidth, we've talked about the latency and the error rate. But factors that affect this include the number of devices, the number of users. So the network's maximum bandwidth is shared between all the connected devices. So the more the devices, the less everyone gets to use. The transmission media. So using Wi-Fi will result in slower data transfer speeds and a greater number of lost or corrupted files. Interference. Wireless and some wired transmission media are prone to electromagnetic interference that can corrupt it, but it tends to just be more wireless. And then obstacles. Physical can protect radio waves from traveling. We've looked at the internet, so I'll skip past those slides. This is a nice little animation to show you what happens when you get a website. So in order to type in the domain name, so firstly you type in the domain name, it then goes to, so the URL then requests the web page, the web browser then to the DNS to send a web server, but it doesn't know the IP address. So then goes to the DNS, gets the IP address, and then comes back. And then what happens is they then request the packet and is sent. Again, a bit more information about web hosting. It's one of the principal users of the internet, and every website is hosted on a web server. A web server is a dedicated computer on the internet that. Okay, yeah, so web hosting principle. Every website has a web server. That makes sense. Web hosting companies also offer service guarantees. So we've actually talked about cloud. Okay, so examples of cloud service applications. We're not talking about that in this topic. Actually, that'll be in the next live stream. Okay, so we've discussed network topologies and we've discussed the layers of a network, but what we haven't looked at is the protocols. So we've looked at the topologies. So in terms of Wi-Fi, Wi-Fi is a set of standards that define how over radio waves. So Wi-Fi is a set of standards, a set of protocols that define how network devices can communicate wirelessly over radio waves. Now it's the opposite of Ethernet. Ethernet is a set of standards that define how network devices can communicate over wired devices. So Wi-Fi is for wireless over radio waves. We're now going to look at network protocols. So what is a protocol? A protocol is a set of rules that defines how data is transmitted between a network or between communicating devices, connecting devices. So there are so many protocols that define the rules for different aspects of networking. So for example, Ethernet. Ethernet is a protocol that defines how data should be physically transmitted through wires. HTTP, a protocol that defines how data should be transmitted between a web browser and a web server. So that's a key information. So HTTP is used for accessing and receiving web pages. So what it does is it allows the web browser to communicate to the web server to receive these web pages. And then Wi-Fi. Wi-Fi is a set of protocols defining how data should be transmitted over radio waves. Now, rules of protocols often include how communicating should start and end, how data packets should be structured, which network port the communication should take place in, how to check if it's been there, and what to do if something goes wrong. Common networking protocols. So here are three common ones. So HTTP, which is the Hypertext Transfer Protocol, and this defines how data should be exchanged between the web browsers, the clients, and the web servers as requests and responses. So HTTP stands for Hypertext Transfer Protocol, and it defines how data should be exchanged between the web browsers and the web servers. HTTPS adds a secure socket layer to it. FTP. So FTP is used for transferring files between a client and a server. and it's used separately for control and data connections. Now we also have some other protocols for emailing. So we have POP, IMAP, and SMPT. So POP, the Post Office Protocol, is a very common email protocol that defines how emails can be received. Email protocols, I'm going to just do it here. Email protocols. So in terms of email protocols, we have POP, IMAP, and SMPT. So let's look at POP. Let's start with POP. Post Office Protocol. So the Post Office Protocol receives and holds an email until the receiver picks it up. And it then checks the mailbox, downloads the mail onto the server using Post Office Protocol, and then creates local copies of the email, deleting the original. So in the steps of the Post Office Protocol, step 1, it receives and holds the email. Step 2, it then checks the mailbox and downloads the mail onto the server. Three, the POP then creates local copies of emails. And these local copies of emails then deletes the original, and any email tied to, and the only email that you can see is then tied to that device. So POP, you receive the email, you then check the mailbox, download the mail onto the survey to the server, and then delete the original. Now, IMAP is a bit different towards this. So IMAP is used. Firstly, it allows viewers to manipulate messages stored on the server as though they were stored locally, and it allows folders, drafts, and things to have simultaneous access on loads of different applications. So IMAP can be used on multiple devices and computers. Emails can be stored on the server. And then the sent email stays on the server, allowing access anywhere. So on IMAP, you have multiple devices. The emails can then be stored on the server. So emails are stored on the server, whereas in POP, the local copy of the email is created, but the original is deleted, and it can only be accessed by that one device. So it's stored locally, but it's not stored on the device. So the main difference is that in POP, it's stored locally, whereas IMAP is stored on the device. And let's just go back to the final topic, which is virtual networks. Okay, virtual networks, which is the final topic of this paper. So, a virtual network is a software-based network that can share the same physical hardware with other virtual networks. So, it allows you to communicate, have an encrypted communication of secure data, and securely connects geographically unrelated computers via the internet. So it's a software-based network that shares the physical same hardware, and it allows two or more devices on the internet to communicate as if they were on the same local area network. Now, a virtual local area network allows an organization to divide one physical network into distinct segments to operate multiple separated networks across the same physical hardware and cabling. Now, advantages of doing this is that it simplifies the network design by having different departments of types of devices on their own network, and also increases the security as devices here communicate with devices as though they were physically connected together, which reduces the risk of an employee accessing systems that they shouldn't have had access to. Now, that is it for the networks topic, and it's good because you're approaching the end of the 2 hour mark. So, well done for tuning in. We've revised roughly the first half of paper one, but definitely the harder half. What we have left is ethical, legal, cultural concerns, data representation, security, and system software. So, much more easier and smaller topics left. So, well done for getting through the harder part of this topic. I'm then going to say good luck for your GCSEs, and do feel free to tune in to any future live streams that I will be conducting soon. See you soon.